Assalamualaikum and a very good evening. Okay, my name is Norasida Farahizzaty and this is my teammate, Muhammad Qaiyum and Nur Atikah.
Okay, allow.
Okay, so for the task 1, we designed the circuit as given here. We can see that there is one source and we use a transistor and LC tank here. So if we simulate the circuit and we put the oscilloscope at the end, which is at this particular point, we get this waveform, and we can observe that the output waveform produced is not modulated. The reason why this is happening is because in order for us to modulate a signal, we need a carrier and a message signal. But in this circuit, there is no message signal. So that's why we can produce a modulated signal. And for the task 2, for the task 2, we use the same circuit, but we add a message signal at the in series with the resistor. As a result, we can see that we can produce a modulated signal. This is because the criteria for a modulated signal is it has to have a carrier frequency that is higher than its frequency, so that it can carry the message signal and produce a modulated signal. So I think that's all for task 2. I'll pass the task 3 to Qaiyum. To Atikah.
Okay, Atikah.
Okay, so for task 3, we're still using the same circuit. It's just that we're changing the value for the V2. That is the voltage for the message signals. So we're varying from 1 volt to 16 volt. And what can we observe is that where we can observe from the plotted of V2 again versus peak VRMS1, that is the amplitude of the highest peak. As we increase the value of the voltage, the output, the highest peak is actually unstably rising. We can see from the trend line, and for the VRMS2, that is the lowest peak, it will unstably decreasing when we increase the value of voltage. So the signal is still modulated because we're still using the carrier, the frequency of the carrier to be higher than the message signal frequency. So the varying of voltage B2 is actually affecting the amplitude of the highest and the lowest peak, and it doesn't change any to the modulated other than the inset amplitude. I think that is all for me for task 3. Next I pass to Qaiyum.
Okay. So Assalamualaikum. So for task 4, it's the same circuit, but then the procedure is to change the V2 frequency, but keep it V1 frequency constant 11 kilohertz and V2 increase from 1 to 16. So as a result, we can see that here and for V2 here. So overall, I would say it's a very unstably high and low, because as we can see here, the difference will tell that the amplitude of the VRMS1 and 2 of the difference. We can see if it's constantly decreasing, the difference will tell the pattern of it. But then sometimes it will increase and sometimes it will decrease. So from here we can see for 1 kilohertz 4.1 and 2 kilohertz 4.2. So until we go to 11 kilohertz, it will become constantly even. So the difference like 0.010. So theoretically, for amplitude modulation to happen is that the carrier message signal must be bigger than the carrier signal frequency must be bigger than the message signal frequency. So that is why we can get the constant result at 11 kilohertz. So I think that's about it. So thank you. Ambil kau.